monitor looks like you're in the wrong place. Look at it now.
Hi everyone. Sorry?
Let me just give you an introduction.
Hi.
And my timer here. Okay. So our next speaker is Praveen Prem from the University of Alberta. And the title of the talk is Functional Brain Activation During Visual Statistical Learning is Related to Rapid Automatized Naming of Digits and Objects and fMRI Study.
Hi everyone. Sorry, I know that was a mouthful. So I'm Praveen, and I'm here to present a very cool study from a very cool project that we did in our lab. So I'll start off with a little bit of background. Statistical learning, what is it? It's just when you look around, you see so many things and we try to make sense of them. There's patterns, right? And this can be applied to so many fields of cognitive science. One thing to note is that statistical learning is mainly implicit in nature. And so let's take an example of how infants learn language through the use of statistical learning. When you see a cute doggy, and then you see a happy cat. Now you see a cute cat. So when you see a happy doggy, how would you form these two words? You see that happy happen together once, doggy happen together once, but P dog never happen together. So those are transitional probabilities. And P have 100% transitional probability here. Dog, P dog doesn't, so that's not a word. The word would be happy dog. That's the simplest example I could think of to explain this. And it's very, very widely applied in the field of language learning and cognitive neuroscience of language. So we have a ton of evidence that infants learn language, like the previous example. They segment words with the help of these transitional probabilities. And it's also a very good predictor of reading ability and disability. So the second part of our paradigm is rapid naming. So it's just spontaneously naming the visual stimuli that you see. They could be alphanumeric, like digits, letters. They could be non-alphanumeric, colors, pictures. They are also very highly predictive of reading ability and disability. But very interestingly, they can predict even before infants learn to read. So what we know in this realm of statistical learning, they're both, we know commonly that they're both highly predictive of reading ability, disability. The neural correlates of statistical learning are very little known. Rapid naming too, ton of things out there. What we don't know is how these things converge. Because they're so close to each other, you would think that we know that center, we don't. And that's what we are trying to find out. So methods, quickly. We took 44 people and we tortured them with an hour of task. We put them for first familiarization phase. This is something very unique to our project. We didn't just familiarize them with the ways to see the brain, how it familiarizes itself with the probabilities, statistical regularities. But we also tested them right after. And then offline tasks, we extended the punishment and made them do rand tasks. We made them do digits, objects, and letters. So imagine you're doing the error, right? That's me. I went in, and this is what you see. Doesn't like much, right? Like, what can you really learn? But what is happening behind the scenes is that all of these objects are in triplets. They are always pieced together, you always see them together, even though they might be randomized. So they were randomized in each cycle, 8 triplets, and for 24 cycles. Yes, that's what I meant by torture. And then we tested them. The test looked like that. If people learned properly, and they knew which triplet was always pieced together, they would know that the second one is the correct answer. And then this is what random task looks like. You have to read them as fast as possible while maintaining accuracy. And then we scored the performance on the basis of number of items correctly recalled per second. So then we used a standard pipeline, pre-processing pipeline using SPM, everything standard, first level analysis, second level too. We used the voxel-wise approach. We had an event-related design, and then one sample t-test was applied, master generated. We used with an uncorrected p-value less than 0.001. Then we correlated voxel-wise with behavioral results from the RAN task. T-maps are associated with learning and test were generated separately. And then we finally made clusters, beautiful clusters. You're about to see them. So this is just the behavioral results. We see that objects have the highest correlation with statistical learning and testing. Okay, moving on. So this is the familiarization phase. We saw a ton of activity for as brain behavior relationship between digits and objects, but none for letters, nothing, which is very surprising. So let's talk about them. SFG. So SFG, we know that it's very important for spatial processing, working memory. So you could think that maybe that part is working a lot in maintaining the objects and registering in sequential learning of the items that people are seeing. Then SMA is very important for visual motor sequence learning. It transfers learning to motor timing. So that's something that we know. Then post-central and pre-central. So it's important for integrating sensory feedback, motor timing. Pre-central is very important for memory representation. IoT, a very important region, has been established in SL a lot. It's important. It's a part of the language network. It's important for integrating spatiotemporal patterns and familiarization of patterns. And you see much more activity when you do SL tasks in them, familiar versus random objects. So then we see a lot of activity in STG. So STG is important in comprehension. It's part of a language network called Visual Word Form Area. So it works in orthography phonology mapping and also lexical phonology, then caudate, another core region in statistical learning. Then we see STG. We just talked about STG. Sorry. My bad. Yeah, I cannot. Okay, it's okay. Sorry. So we just talked about caudate. Another region that is surprising to see here is tree fields because it's a pretty important region in the evolved mode network, and it has been seen a few times in SL projects, but not a lot. So we see that we know that it has a role in visual spatial imagery, rotation, comparison of images, in episodic memory retrieval. It's also important when you have to direct your attention from one thing to the next. So you might think that maybe they're trying to, in the back of their head, piecing triplets together as they're moving. Just remember that this is happening very unconsciously. The process of statistical learning is unconscious, implicit. Then, left middle temporal gyres, so MTG. This is a region where beginners have a lot of activity in when they're learning to read, which diminishes with time. People with reading disability, they don't show this progression in pattern. So it's interesting to see MTG here as well. It's important in heteromodal network. It integrates retrieval with the semantic context, making sense of what you're retrieving. FFG, a very core region in SL again, and it's very highly involved in alphanumeric learning. So it's important for orthographic information and visual word recognition. So it's tuned to sublexical orthography structure. What that means is trying to form words with seeing microstructures in letters. And it's also important for novel word learning, lexical semantics. It's a part of a lexical semantic for the heteromodal meaning of words and pictures, which makes sense why it's highly correlated with digits here. Then lastly, my favorite, cerebellum. Again, it's very important for sequential learning, motor timing. It's interesting to see it working on both sides. And again, cerebellum is highly active in any sort of learning. So, yeah. Okay, and then yeah, emoji, visual cortex, and parahippocampal gyrus. Yeah. Okay, moving on to the testing phase. Again, I love these numbers. So again, lots of clusters in the digits, but very few objects. Again, absolutely none in letters. We see nothing here. Again, we'll type directly into clusters. Precentral gyrus. So again, you could attribute that to finger tapping because testing, do note that testing is done with remote in a hand with the MRI. You have to select the options, and then again, you see precentral, postcentral gyrus. But again, just because it's motor doesn't mean it has been established to be working in SL a lot. We just talked about SFG. My discussion would remain the same here as well. Interesting to see VC insula here. I didn't know that it has been also found in previous SL studies. So you could say that it might play a role of maintenance, maintaining while you're trying to retrieve what you just learned, because it's part of verbal working memory, and coordinating motor aspect, integrating what you're seeing with retrieving them. So it's important for articulation. We saw MFG just a while ago. STL, it's another very widely seen region in these projects. So it is important, again, it has a role similar to SFG. It integrates visual spatial memory with motor information. IPL is a grapheme to phoneme correspondence system. It's a part of that system. So it's crucial for integrating the structure that you're seeing with the phonological information. It's important in language training in people with aphasia. So Cuneus, it is attributed to visual and spatial processing. So it contributes a lot to the accurate and quick retrieval of visual information in naming tasks. You see that a lot. We have just a minute. Lingual gyrus, it's associated with recognition of prints, so you could say that they're trying to identify what they're seeing, and then try to recall it as fast as possible. It is very important in encoding, and it's also found to work with visual word form area. And precuneus, we talked about. Favorite cerebellum. We should know that this is predominantly on the left hemisphere, which is the pattern that you see with languages, and then the classic. Yeah. So what we learned from this, that you saw both phases of visual statistical learning were strongly related to rapid naming of objects and digits, but not letters. This was very surprising, again. So not just the familiarization, this adds a second degree of excitement and novelty to our studies, which is that we also have involved testing, not just familiarization. And so we see a very high involvement of visual word form area, language learning network, reading regions, everything that we saw. And it was interesting to see high involvement of these regions that we did not really expect before, but now that we see such high involvement, we got to look into it. So might not look a lot, but we're a step closer to solving that missing piece in the literature that we have. And I believe that if it gets out there, it's a contribution to the field, for sure. I want to thank the most awesome and best supervisor in the world, Jacqueline, is sitting here, and the rest of the lab who made this project happen. It ran for months and months and a whole year, but we're finally done, and very excited to show it to the world. And thank you everyone for